Good morning, guys. Today we're going to be looking at some notes over section 2.1, our new chapter. This section is over linear equations, so we're just going to be solving some equations. So most of this is going to be review for you, but it's a nice refresher for you. The first thing that we need to talk about before we solve any kind of linear equations is domain. Which is the set of reasonable values of a variable. And anytime we solve an equation, especially one where we're dealing with fractions or where we're dealing with square roots, which will come at a later time, we always need to check our answer and make sure that it would make sense in the original problem. And we'll look at an example of that here in just a little bit. Okay? So let's just jump right in and look at a couple of examples of solving an equation. All right, so the first equation that we're going to solve is 5x minus 9 equals 3x plus 7. Keep in mind that when we solve equations, we are trying to isolate x. We are trying to get x by itself so that we can know the value of the variable. So in this case, we are going to try to get all the x's together on one side using inverse operations. So I'll subtract 3x on both sides. And I need to get all of the numbers on the other side. So in this case, I will add 9 on both sides, so that I end up with 2x is equal to 16. And lastly, we will divide both sides by 2, and we find out that x equals 8. And we need to know if that's going to be a reasonable value in our equation. And we can tell that if we put 8 back in place of x, we wouldn't have any problems. We wouldn't come up with anything that was undefined. So that one's okay. The second equation that we're going to solve looks like this. 3 plus w over 6w is equal to 1 over 2w plus 4 over 3. Now, this is an equation that begins with some fractions. The easiest way to solve an equation that begins with fractions is to get rid of the fractions in the beginning. And the way that we do this is that we multiply every term in our equation by the common denominator of all of the denominators. So if I look at 6w, 2w, and 3, I'll find that I need to multiply everything by the common denominator, which is 6w. So I'm going to show that this way. Some brackets. And I'm going to kind of show you the way that this works. We're going to give everything, each term, a factor of 6w. When I do that, I end up with 6w times 3 plus w over 6w is equal to 1 times 6w over 2w plus 4 times 6w over 3. Okay. And once I have that, I can do some canceling. So those 6w's will cancel to give me just 3 plus w. Over here I have 1 times 6w over 2w, so I'm going to be able to cancel the w's, and then 6 over 2 is just 3. And then in this case, I'm going to be able to cancel this 3 with the 3 out of that, and I end up with 4 times 2w, or 8w. And then this now becomes a very simple linear equation for us to solve. Ooh, drop the board. Okay. So I'll subtract w on both sides, and I'll also subtract 3. Well, when I do that, I get 3 minus 3, which is 0, and w minus w, which is 0. Here, 3 minus 3 is 0, 8w minus w is 7w, and we would solve that by dividing to find out that w equals 0. Now, the problem with this, though, is again, we need to always check our answer in our original problem. If I were to put 0 in place of w in the original problem, I would end up with 3 divided by 0 on the left, and on the right I would end up with 1 divided by 0. And we know that anything divided by 0 is undefined, and so that's a bad thing. So we cannot have that. So this is actually not a solution. This equation actually has no solution, and that's how we can show it. Okay? This is actually what we call an extraneous solution. Okay? So the actual answer there is that there is no solution to this equation. Okay? All right, I have one more for us to look at. So let me erase a little bit. So this is example number 3. It is 2x minus 3 over x plus 1 is equal to 2 minus 3x minus 1 over x plus 1. So again, we're starting with a problem where we have fractions. And again, the easiest thing to do is to get rid of the fractions to begin with so that we don't have to deal with them at all. So I'm going to do that by finding the least common denominator between the two denominators. Well, these two denominators are the same. So I'm going to multiply everything in this equation by x plus 1. So I'm going to end up with, on the top here, 2x minus 3 times x plus 1. Notice I'm using parentheses there, all over x plus 1, is equal to 2 times x plus 1 minus, again, parentheses, 3x minus 1 times x plus 1, all over x plus 1. And we can see then, again, very quickly that the x plus 1's cancel here and here. So that I'm then left with 2x minus 3 is equal to 2 times x plus 1. And notice that I'm going to keep this in parentheses, and it makes a big difference because we have a minus sign right here. So everything inside of here is going to need to be multiplied by a negative. Okay. So we'll go ahead and solve 2x minus 3. We need to do some distributing here. So we get 2x plus 2. We distribute this negative to give us minus 3x and positive 1. Combine some like terms. So 2x minus 3x is negative 1x. And then 2 plus 1 is 3. And we're almost done now. We'll add x to both sides. And we'll add this 3 to both sides. So we end up with 2x plus 1x, which is 3x, is equal to 3 plus 3, which is 6. And finally divide. So we find out that the solution here is x equals 2. But again, anytime we solve an equation, especially one that involves fractions, we need to make sure that this answer makes sense in our original problem. And the only thing that would not make sense is if I were to put in 2 in place of x and get a 0 in the denominator of a fraction. In this case, it's actually okay because I would get 2 plus 1 in the denominators, which is not 0. So this is actually our solution. Okay. Okay, I have one more thing that I want to mention before you get started on your assignment today. Sometimes we solve equations, and I'll just try to quickly think of a couple that I can use to demonstrate this. For instance, if I have something like 2 times x plus 1 is equal to 2x minus 12. Now let's make that 9. 2x minus 9. Okay? And if I try to solve this one, I'm going to get 2x plus 2 is equal to 2x minus 9. When I solve this, I might consider subtracting 2x from both sides. And also maybe subtracting the 2 from both sides. Well, 2x minus 2x is 0. 2 minus 2 is also 0. 2x minus 2x is nothing. Negative 9 minus 2 is negative 11. So I end up with something like 0 equals negative 11, which is an untrue statement. Okay? Untrue. So when you're solving an equation, if the variables end up canceling out completely and you're left with a statement like this that is untrue, then this equation will have no solution and this will be your answer. Okay? So that's one type of problem that you might run into today. Let me show you one other one that you might run into. Let's do 3 times x minus 2 plus 4 is equal to 3x minus 2. Okay, so again, we're going to just solve this equation the way we would normally. So we'll start with distributing here. So we'll get 3x minus 6 plus 4 equals 3x minus 2, or 3x minus 2 equals 3x minus 2. And again, if I try to solve, I would maybe subtract 3x from both sides and add 2 on both sides. And what ends up happening here is that I get 0 equals 0. And what we know is that this is always true. So remember, we had 2 on the last example. We had a statement that was untrue, never true. And in this case, we have a solution that is always true. And in this case, we have what we call infinitely many solutions. Okay. Now, you will notice when you're talking about infinitely many solutions, this is the way that we write the answer. You may not substitute the infinity symbol for infinitely many. Infinity is different than infinitely many. Okay, so don't do that. So go ahead and write out the whole thing, infinitely many solutions. All right, if that's what you end up with. Okay, that's all the examples that I have for you today. So you have an assignment that is a document on Canvas that you need to get to work on. Put it on another sheet of paper, obviously, and make sure that you show all of your work. All right, next time you'll look at the answers for that and then watch the next video for Chapter 2. All right, good luck and have a great day. Bye-bye.